Today we're going to look at Chapter 6, which has to do with ratio, proportions, and percents. So first, I want to make sure that we are comfortable writing percents and going back and forth between a percent and a decimal. So a percent, so for example, 50%, will have the little percent sign. And if you want to write a percent as a decimal, what you do is you take the current decimal, which for the 50 is understood to be here, and you move it to the left twice. So I'd move it 2 times. So 50% is 0.50, or just 0.5. You don't have to put the extra 0 when it's at the end. So we'll look at another one. Let's say that you had 27.5%. If I were to write that as a decimal, I would take the current decimal and move it to the left twice. 1, 2. So that would give me 0.275. So 27.5% and 0.275 are equivalent. They have the same meaning, but the decimal here is going to be our preferred version mathematically. So we'll do one more here. Let's say I have something like 3.5%. So if I wanted to write that as a decimal, I'm going to divide by 100, which means move the decimal to the left twice. I'm going to move it 1 time. Okay, so here I can only move it once, which means I have to add a 0 so that I can move it twice. So 3.5% is 0.035. So it's a really simple thing, but you have to be careful to make sure that you don't forget that, or it's going to cause a lot of problems. So we'll do, I lied, I said one more, but I'm going to do a couple more. So 5% as a decimal would be 0.05. I would take the decimal where it was, it's understood to be here, move it to the left twice, and then let's say I had something really small like 0.04%. So to get rid of that percent symbol, to write it as a decimal, I'd have to move the decimal to the left twice, which means I would have to add 2 zeros. So that's 0.0004. Okay, so moving on, now we're going to actually start some percent problems. So first we're going to work with percent problems equations. So some key things to remember. The word of means multiply. So if you see the word of, you can write multiplication, your little dot. When you see the word is, I want you to envision an equal sign. And whenever you're asked something like what number or what value, I replace that with a variable. So an X or a P or a K or whatever I want. So we'll just jump right into an example. So it says, translate to an equation. 15 is what percent of 20? So let's say that I want to solve that. I want to answer it. So the best way to attack these problems, to answer them, is to rewrite them with symbols and numbers. So I'm going to start with 15 is obviously just, a number, 15. But then the word is, I remember, is an equal sign. What percent? Here's my unknown, my variable. I don't know what that is. So maybe I call it P or K or X. I'm going to call it P in this problem. What percent? That's my unknown. That's my variable. Of means I'm going to multiply. And then 20. So I have an equation here. Now I can solve for P just like I would any equation. So I guess the cleaner way to see this, it would look like 15 equals 20P. That's how we typically see it. It's the same thing though. So if I said, okay, I want to solve for P, let's undo what's happening to P. It's being multiplied by 20, so I divide both sides by 20. So that goes away. 15 over 20. I would actually type that in my calculator. This one I actually know without a calculator, but we won't always know that. So I get 0.75. So it says 15 is what percent of 20? So I know I want to give my answer as a percent, so that would be 75%. And I've got my answer. Let's try another one. It says 2.4. Okay, I'm just going to look at the number 2.4. I'm going to write an equation again. Is, so I've got my equals, 25%. So when you're doing these problems, you never want to have the percent sign in your equation. It's not something you should ever see because it's not something you should do. So I'm going to write 25% as a decimal like I did earlier. So here I have 2.4 is 25% of means I'm going to multiply. Remember, I'm going to put parentheses this time for multiplying. Of what number? So that's my unknown. What number? I don't know. Let's call it X this time. So now I can answer that question much easier now that I have an equation. So 2.4 is 25% of what number? So now that I wrote it out, I can tell to solve for my X, my unknown, I undo multiplying by 0.25 by dividing by 0.25. So my X will be alone. And for 2.4 divided by 0.25, I would for sure type that one in a calculator. And I get 9.6. So it says 2.4 is 25% of 9.6. So the key is always remember your percent. When you're writing an equation, you'll want to change it to a decimal. You will not want a percent sign in your equation. We'll do a couple more here. What number, so maybe this time I'm going to call it W, why not? What number is 50%? I'm going to write it as a decimal. 50% of means I'm going to multiply. So I'm going to have of multiply. I could write an X, but I don't like using it. It looks like a variable, so I'm just going to say I'm going to multiply by 0.6. So here I have what number is 50% of 0.6. So of means multiply. So here I can tell my variable's already alone. All I need to do is take 0.5 times 0.6. So I'm going to do 0.5 times 0.6, and I get 0.3. Now maybe I didn't need to write an equation here. Had I just read it and thought about it, what number is 50% of 0.6? What number is half of 0.6? 0.3. But sometimes I do need an equation, and so it's really good to practice setting those up. What's this? Here's another one. You might want to pause it and try. Unpause it and check. What number, we'll call it N, is 45%, so 0.45, of means I'm going to multiply, of means multiply. So what number is 45% of means multiply? 80. And here again, my variable's already isolated. I'm not even really solving an equation. I'm just going to type in my calculator 0.45 times 80, and I get 36. So N is 36, and then I can always think about it and see if it makes sense. What number is 45% of 80? 36 is 45% of 80. It makes sense. It sounds logical. Keep trying here. 65% of 90. So I'm going to multiply by 90 is what number? So I can just keep practicing. And I multiply and I get 58.5. So you kind of see sometimes I'm setting it up and I'm solving for X. Sometimes when I write it out, I've got my answer. I know exactly what to do. Okay, haven't done one like this in a few minutes. What percent, I'm going to call that X, of 35 means I'm going to multiply by 35. Sometimes I draw the dot for multiply, sometimes I do a parenthesis. Either way is fine. So what percent of 35 is 21? So this time I have an equation I need to solve, unlike the past two examples. So if I want to solve for x, I have to undo multiplying x by 35 by dividing both sides by 35. So I'm going to divide both sides by 35. So x is 21 over 35, and I don't know what 21 divided by 35 is. So I'm going to type 21 divided by 35, and I get 0.6. So there's a catch here. This one, the question said what percent? So I need to convert my answer to a percent because it asked for a percent. So if I have a decimal to a percent, I need to move the decimal to the right twice. So if I move this to the right twice, I get 60%. So now that we've looked at how to calculate percents and how to solve percent questions, we're going to apply that with some word problems. So here we have 18% of Frank's wages are withheld for income tax. Find the amount withheld from Frank's wages of $3,680 per month. So the good thing about word problems is you can always think about a reasonable answer. So if you're doing something here and you get like $3, that doesn't make sense. If you get like 36 cents, doesn't make sense. 5,000, that doesn't make sense. So I can already kind of look and see like what makes sense. So what I'm being asked here, when I think about it, is I'm being asked what is 18% of his wages. So what is 18% of 3,680? So here's where I'm going to use my equation. So what is 18%? And I need to make that a decimal, so 0.18. Of means multiplication. So I'm going to multiply that by 3,680. So I'm going to take 0.18 times 3,680. And I get 662.4. And that makes sense. $662.40. Unfortunately, that sounds about right. So let's try another one. It says, Mr. B, the principal of Slidell High School, counted 31 freshmen absent during a particular day. If this is 4% of the total number of freshmen, how many freshmen are at Slidell High School? So the first thing I notice is 4% is not very much. So if 31 is 4%, total, there's much more than 31. So I'm thinking my answer should be much more than 31. So first I'm going to write it out. 31 is 4% of what number? So I'm saying 31 freshmen is 4% of what total freshmen? So I've got 31 is 4% of what number? So now I'm going to change that 4% to 0.04. And when I change that, I divide both sides by 0.04, and I get 775. So that sounds really good. 775 freshmen in the school. Sounds reasonable. So now we're going to look at something called percent of increase. So a percent of increase, right here, is the amount of increase over the original amount. So percent increase is the amount of increase over the original amount. Then it says write the quotient as a percent. Remember, quotient means divide. So write your answer after you divide, write your answer as a percent. So it's easiest just to do examples here. So it says the average soft drink size has increased from 13.1 ounce to 19.9 ounce. Find the percent increase. So first I've got to figure out how much did it increase. So percent increase is supposed to be the amount of increase over the original. Well, how much did it increase? So that's my first step. So I'm going to subtract 19.9 minus 13.1 to see that's how many ounces it increased. So next, now that I found my 6.8, my percent increase is the amount of increase over the original. So my amount of increase, it increased by 6.8 over my original, which it started out 13.1, and then I just divide. So when I divide, I'm going to get a decimal, and I wanted my answer as a percent, so I moved the decimal to the right 2 times. That is percent increase. You might screenshot that. It's the amount of increase over the original, not the new amount, the original amount. So percent decrease is going to work the exact same way. I'm going to take the amount of decrease over the original amount and write my answer as a percent. So amount of decrease over the original, write your answer as a percent. So here, John Smith decided to decrease the number of calories in his diet from 3,250 to 2,100. Find the percent decrease. So first I need to figure out how much it decreased by. So my amount of decrease is what I need. Well, to do that, I need to subtract what he's eating, what he was to what he is now, what he's eating. So I do 3,250 minus 2,100. That is my amount of decrease. So figure out the difference. To find the percent decrease, I'm going to take what he decreased by over the original. So I'm using the formula. The amount of decrease over the original. Here's my answer in decimal form. So percent would be 35.4. So he decreased his caloric intake by 35.4%. So lastly, and it all goes together, we're going to look at problem solving with percents, this time using sales tax, commission, and discounts. So we're thinking about when things are on sale or when you're paying tax. So sales tax is your tax rate times the purchase price. And we probably use this in real life a lot. And then total price is the purchase price plus your sales tax. You might screenshot that if you need. So here I have a gold and diamond bracelet, sells for $1,800. Find the total price if the sales tax rate is 6.5%. So the first thing I need to do is figure out the sales tax. So here it says sales tax is the tax rate times your purchase price. So what's the tax on that? I'm going to take 6.5% times 1,800, and do not forget to make that 6.5% a decimal, or you're going to get way too much tax. So my sales tax, 6.5%, times 1,800 gives me a sales tax of $117. So here's where you might be tempted to type your answer and move on. But I was asked for the total price. So I need to add that 117 to the price of the bracelet. So my total price will be $1,917. So I'm going to do my tax rate times the price, being really careful to make sure to change your percent into a decimal. And then I'm going to add that to the original. So this one's a little bit different. This time you're being told the sales tax and you're being asked for the rate. So the sales tax on an $18,500 automobile is $1,665. Find the sales tax rate. So I'm going to use R for my variable. So sales tax is tax rate, sorry it didn't show the image, times purchase price. It's the same formula we had here. Sales tax is tax rate times purchase price. So this time my variable is somewhere else. I know my sales tax, $16.65 is what I was told. My tax rate is an unknown. I don't know it, so I'm going to put an R or a K or whatever. And then this dot here, right here, this is supposed to be a multiplication sign. Not sure what happened. Sorry about that. So I'm going to put my multiplication. So to figure out the tax rate, now that I have an equation, I can see, oh, I need to get R alone by dividing both sides by 18,500. So when I do that, this will cancel out right here. R will be all alone. So for sure I'll want a calculator. I'll divide 1,665 divided by 18,500 and I get 0.09. We don't give sales tax in terms of a decimal. We tell it in percent. So I'm going to need to change that to a percent. My tax rate is 9%. We'll do one last problem, and then I encourage you to go ahead and start the homework and get it done as soon as possible. It says a $2,000 designer dress is on sale for 30% off. Find the discount and the sales price. So first I'm going to find the discount. So if something is 30% off, well, how much is that off? So what I need to figure out is, what is 30% of 2,000? So I need to figure out, well, what is 30% of 2,000? It's an expensive dress, right? So here's where I'm going to use my equation skills. 30%, I'm going to write 0.30. Of, I'm going to change to multiplication. 2,000. So if I figure out 30% of 2,000, I just do 0.3 times 2,000. I'm going to type that in my calculator here. And I get 600. So 600, you have to be really careful here. 600 is the discount. So the discount is 600. That was not the entire question. So the discount is 600. Now I want the sale price. So the sale price is going to be the 2,000 that it was listed for minus the discount. So when I take my sales price, subtract the discount, it is still crazy expensive, $1,400. There we go.